Welcome to this class. In this class, we're going to give more examples of application of product rule for differentiation. So problems. Find the derivatives of the following. So A, we have y equals to sine x cos of x. B, we have h of x is given by 3x minus 2x squared multiplied by 5 plus 4x. Let's solve these two problems first. Now, by definition, product rule is given by dy dx equals to u prime v plus v prime u. So for A, we say let u to be sine x and v to be cosine of x. Now this implies that u prime is cos of x, and this implies v prime. Derivative, of course, is negative sign. So dy dx is given by u prime v plus v prime u, which will be u prime is cosine of x times v is cos of x, and then plus v prime is negative sine x, and then u is sine of x. So this will give us cos squared x minus sine squared x. So that would be the derivative of that function. And using trigonometry, you can simplify it as this is the same thing as saying cosine of 2x, since we know that cos of A plus B is the same as cosine of A cosine of B minus sine of A sine of B. So cos of x plus x is cos of x sine of x sine of x, and then this is the same as cos of 2x equals to cos squared x minus sine squared x. So this and this are the same. And then question 2 of B, we say let u to be the first bracket, which is 3x squared, 3x minus 2x squared, and v to be the other bracket, 5 plus 4x. Now by that, this means that u prime is 3 minus 4x, and this means v prime is 4. So dy dx, which is the same as h prime of x in this case, is given by u prime v plus v prime u, so which will be 3 minus 4x times 5 plus 4x plus v prime is 4 into u, which is 3x minus 2x squared. Now, this being a simple product of two linear functions, we can always expand, and so we'll have 15 plus 12x minus 20x minus 16x squared plus 12x minus 8x squared. So we'll have 15, 12 minus 20 minus 8 plus 12, that's 4. So plus 4x minus 16 minus 8 is minus 24 x squared. So we have minus 24x squared plus 4x plus 15. This is the derivative of a given function. And C, we have y equals to x e raised to x. So this one, we let u to be x and v to be e raised to x. So this means u prime is 1, and this means v prime is e raised power x. So dy dx is given by u prime v plus v prime u, which will be u prime is 1 times v is e raised power x plus v prime is e raised power x times u is x. We have e raised power x plus x e raised power x, which is the same thing as saying 1 plus x multiplied by e raised power x. So this is dy dx. And then d problem D, we have y equals to 2x cosine of x minus 2 sine x. Now for this question, this part here, we let this one to be u and then this one to be v. This one is just in the correct form to differentiate. So dy dx will be given by u prime v plus v prime u, and then the derivative of this part would be negative 2 cosine of x, which will be u prime. Derivative of 2x is 2 times v, so will be 2 cos of x, and then derivative of cos is negative sign, so plus minus is minus, and then 2x sine of x, and then minus 2 cos x, and this cancels out, so we have minus 2x sine of x. So that becomes the solution to the problem D. And lastly, E, we have y equals to x cubed into 2x squared plus 1. Now, solution for this, we say let u to be x cubed and v to be 2x squared plus 1. So this means u prime is 3x squared, and this means v prime is 4x. So dy dx is given by u prime v plus v prime u. So substituting, we'll have 3x squared times v, which is 2x squared plus 1, plus v prime, which is 4x, and then you multiply by u, which is x power 3. Then opening the brackets, then plus 4x power 4, and then 6x power 4 plus 4x power 4 is 10x power 4. So this will be 10x power 4 plus 3x power 2. So that is the solution to part E. So thank you, and also next session will give more examples on product rule.